Hey everyone, welcome to the last episode of this series where we are building this beautiful progressive web application with full offline support. In this video, we're finally going to wrap it up and add service workers to our front end. So let's get started. Alright, in order to transform our application into a progressive web application, we need to generate icons. So the icons that are compatible with devices and operating systems. Next, we need to add PWA Config to vite config file. And after that, we need to write a custom service worker for our application to support pre-caching and caching API routes. So let's start with the first one. All right, to generate our set of icons for the PWA manifest JSON, we can use a CLI tool provided by vite PWA. So it's going to generate a bunch of assets based on the paths that we provide. I have a logo image inside my public folder. You can access it with the links in the description. So we're going to generate our assets using this logo.jpg. All right, here inside the console, we're going to generate our assets. Alright, as you can see, it generated 3 icons, the minimal icons that we need for a PWA app. The icons are inside the public folder. So now let's add our configurations inside vite.config.ts. And next, inside the plugins, we need to call this vite PWA with our custom options. We're going to set dev options to enabled. We're going to set strategies to inject manifest. So since we are using our custom service worker, we need to set the strategies to inject manifest. We defined our source directory as src folder. And our service worker file name is going to be sw.ts. And we're going to set register type to auto update. So our service workers will automatically be activated without us doing any operations. And inject manifest swdist is going to be our service worker path after the build operation. And finally, we need to define our manifest object, which is going to contain our PWA information. Here inside the icons, we need to add the names of the icons that we've generated here inside the public folder. You can also use this object here, so you don't need to manually add every icons yourself. Also note that start URL property will be the first route that your users see when they open up your PWA app. Alright, we are done with the config file. As you can see, the compiler is yelling at us since we don't have a sw.ts file inside our src. So let's head over to src folder and define a sw.ts. Alright, before we start writing our service workers, we need to change two files here. First of all, we need to change the tsconfig file in front end folder and add this web worker to our lib property. Next, we need to add a bunch of tags to this head element. As you can see here inside the vite PWA document, it's basically mentioning that we need to at least provide these resources, links and meta tags to our head. It's the minimum requirements for a PWA. Alright, hit save, and as you can see, this is our logo. It's barely visible, but it's working. So now we can write our service worker. Alright, here we are using clean up outdated caches and pre-cache and route from Workbox pre-caching package. So we're basically cleaning up our browser cache, and right after that we're going to pre-cache our assets for our offline support, and we're also going to call escape waiting function so our new service worker gets registered right after we publish a new one. Alright, before we continue, let's go ahead and build our application so we can see what we have done so far. So I'm going to stop the development server and I'm going to run build command. As you can see, the vite PWA package detected our sw.ts file, our service worker. So basically, vite PWA package generated a sw.js inside our dist folder right over here. This is our service worker. So now if we try to run our production build, alright, this is our application running on production build, and as you can see, it's already installable, and this is our icon that we've set before, but we're not going to install it. We're going to check if our application is going to serve as expected in offline mode. So as you can see, the service worker sw.js file, our service worker is registered and activated successfully. So if we try to make it offline and we try to reload the app, as you can see, our image is not loading, and if we try to navigate to our application, you can see our tasks is not loading, and we cannot see any task here. So this is our next step. We're going to ask our service worker to cache the files that we've used in our application, and also the API calls that will fetch the tasks and resources from the server. Alright, I'm going to stop the production server and run our application in development mode. Alright, here we need to do a couple of things. First, we need to cache API call, and we also need to cache images that we've used inside our application, for example this banner image, and we also need to cache our navigations. So every navigation route that we have in our application, we can also cache that using our service worker. And finally, we need to add background sync functionality to our submit API call. So whenever we're trying to make a change to our backend and, for example, submit a new task in offline mode, we're going to also cache that. All right, I'm going to start with caching images. All right, this is how we basically cache a resource, in this case an image or images, using service workers. So we basically try to register a route using the register route from Workbox routing, and we define a route and we add that route to register route. So here we are basically defining a rule that will catch every resource request with destination being an image. So then we will add a cache first strategy to our route, and this will ensure that whenever we need this resource, the system will search for the resource in the cache first, and then it will ask the resource from the server. All right, next we're going to cache our API calls. Basically, we are caching the request for fetching our tasks. All right, here we are doing basically the same. We're defining a new route, and with the network first caching strategy. So basically the system will first request for the resource from the network, and if it fails, it will try to use our cache for that resource. And here we also need a quick refactoring, since we are using the base URL here and inside our service.ts, we're going to add this to our environment variable and use our environment. All right, here we defined a .env file in the root of our frontend project, and we've added our API base URL. So now we are going to use it in our service.ts file and sw.ts file. All right, now the next step is to also cache our navigations. All right, here we've used a navigation route imported from Workbox routing. So we are basically using network first strategy here, same as the API route. Next, we're going to finally implement our background sync functionality, which is going to help us cache and submit our post and patch request to the server. All right, this is our two post and attach requests that we're trying to cache. So we're basically using network only caching strategy. The background sync plugin that we provided here will try to recall the route when our network connectivity is back. All right, the last thing we need to change here is to rename this environment variable and prefix it with vite. And here we also need to change this route to /task/create, and we're also going to change this to includes. So the edit routes will have this URL whenever you're trying to basically check a new task. All right, now we can build our application and test it on production mode. I'm going to stop the development server and run the build command. All right, this is our application in production mode, and let's navigate through the pages. This is our tasks, and we can submit new task from production. And as you can see, everything is working fine. So now let's test the check feature. All right, now we're going to test the offline mode. Now let's reload our application. And this is the app in offline mode, and we are basically serving every asset from the cache. So we can also see our tasks being served from the cache. If we take a look at the cache storage here, we can see that we have our API fetch tasks, navigations, and images. So the welcome page asset is cached here, and also the tasks route with the response is cached here. And if we take a look at the network tab here, we can see that our network requests are failed, but we are serving it from the service worker.js. All right, now let's test our submit task form in offline mode. I'm going to open network tab, and I'm going to submit a new task in offline mode. So hit submit. As you can see, we get an error saying that task is not created because obviously our network request failed. But as soon as we connect our application to the network, you can see our request automatically sent to the network to our REST API, and we get a 200 status. And we can see our task is created successfully. Basically, same things happens when we check a task in offline mode. So if we try to go offline and try to check a task, we can see the network request is failed. And when we try to connect our application to network, it's being sent to the REST API, and it's getting 200 status. So for improving the UX experience, we can do some changes to our error handling so the users won't get error message when the application is in offline mode. All right, let's open our create form. Here inside the create handle form, we can try to check if the application is offline. All right, here we basically try to check if we are in offline mode. We try to show a success toast and reset the form. We can also do the same UX improvement here in task item. And we also need to check the offline mode here. All right, here we are checking if we are online, then we are going to fetch the tasks again when we are changing the state. So we don't want to refetch the tasks from the cache when we are changing the state, because it's basically going to reset it to the original state. So let's go ahead and test that in production. I'm going to stop the server and try to build it again. Alright, let's reload the application. Keep your eyes on this number, the activated and running service worker. And as you can see, it's basically automatically updated, and our new service worker that we've built using our last build command is injected to the application. Alright, let's test our create task form first. So I'm going to switch to offline and clear the network. Alright, let's submit this task, and there we go. This is our success message, but we are seeing a failed network request. If we try to get back the connectivity, we can see that it's successfully being submitted. So now we should be seeing a new task. Yes, it is. So it's working fine. So now let's test our checking functionality in offline mode. So we get back to offline mode and we try to check the last one that we've created. We successfully checked the last task and the network request is failed. And now if we connect again, you can see it's basically automatically sync the client state with the backend. So basically our application is working like a native mobile application where we have offline support for most of our features. Alright everyone, finally it's time to test our application on a device. So we're going to be using iPhone 15 simulator. If you're using Windows, you can use Android simulator. But first we need to make some changes in our code base to improve our application UI. So first we need to head over to config.ts and we're going to set theme color and background color to our body background color, the same that we've set inside index.css. And next we're going to head over to index.html, and we are also going to set the same color here in content of a theme color and the color of the mask icon. Alright, the last step is to add a beautiful splash screen to our application. I've included a bunch of splash screen files that you can download using the links in the description. So we're going to basically add these to our HTML head section. Here I've added links to our splash screen resources. Alright, now let's build our application. Alright, now inside the simulator, let's open our Safari browser and let's open our application. Now let's add it to our home screen. And there we go. This is our application installed on an iOS device. The application shows our splash screen for a moment, and then our welcome page is presenting to the users. And this is it, guys. This is our fully functional PWA with offline support. I hope you enjoyed the tutorial. Share it with your friends, subscribe to the channel, and I will see you in the next videos.